So last time we discussed about the dry etching and compare with the wet etching, and I said we can have anisotropic etching with dry etching technique. Okay, so this is an isotropic etch, and we have undercut, as you can see here. But if you do the dry etching, then you can see that we have just a right angle, and we can transfer the mask patterns into the wafer directly in the same scale, because we don't have undercutting in this case. Now, so obvious, the advantage of dry etching is obvious. Wet etching, isotropic, and the chemical waste problems and potential problems with surface wetting bubbles, grain boundary effects, etc. But in dry etching, anisotropic or isotropic, we can control that, okay? And better dimensional control, of course. And in this table, a number of equations for possible fragmentations and recombination. Fragmentation means in the CF4 gas, for example, you can generate F atoms, okay, not ions, F atoms, by this fragmentation. And this, with this fragmentation, this F atom is important for the etch. Recombination, this fragmentized F atoms is going to recombine with the CF3 to form a CF4, because the CF4 is a stable form of the carbon fluoride. Okay, and the etching happens with this F atom with the etching substrate. Okay, so this F or CF3, those two fragmentized elements is going to work as an etchant to etch silicon or silicon oxide or silicon nitride in this fashion. Okay, so how we can fragmentize the CF4? We use a plasma. Here, ionized gas consisting of nearly equal numbers of positive ions and electrons. We can create equal number of electrons and ions in the plasma. In other words, we apply the energy to create ions and electrons. It's usually provided by the RF source. Okay, this is the radio frequencies. Okay, and we apply the high voltages to the gas here. Then we can create the ions and the neutral atoms, and it is called the fragmentized. So CF4 plasma generates both neutral, especially the F atoms and ions. In plasma etching, the neutral species F are the most important, because that is going to react with the silicon or silicon oxide or silicon nitride, as you can see in the table. Any material with which forms a volatile fluoride, a chloride, and chloride are the major compound after the etching. Okay, can be plasma etched. We prefer the fluoride instead of chloride, because chloride is very corrosive. It is very toxic and corrosive. Fluoride is also toxic, but it is not that corrosive compared to the chloride. So any material form of fluoride or chloride, we can use to etch in a dry etch by forming plasma but the chloride is more corrosive than the fluoride, so we prefer the fluoride. Copper, for instance, the lowest resistivity materials, so that it can be used in electric wires and everything. One of the problems with the copper is that it does not form a fluoride or chloride. So in case of copper, we cannot